so I don't. Yeah, thanks for hitting that. Okay, so just as it says here on the whiteboard, just for those who are probably listening on the recording for this, just a reminder, no work session tomorrow because of the holiday. There is a
Oh,
work
okay.
session on Saturday though.
Oh,
And
there is on Saturday. Sorry, Thomas, did you say Saturday is there? Okay,
yes, it is on Saturday.
but
Yep,
not tomorrow. Okay,
not tomorrow.
thanks.
Yep. Yep. There is on the week after will be normal with the Friday, but not the one on Saturday, is it
Nine
not?
to 12.
Yeah, thank you. Thank you. 9 to 12. Yes. And assignment one coming due on Sunday. Just a little housekeeper reminding me. Okay, so let's get going here. Move everything around. Andrea, the way that DSI works for like the pass fail is essentially if you have not received an email from the instructor at the end saying that you have not passed, it means you have passed. So it's kind of like a no news is good news thing. So if you've done your work for Shell, for example, and you haven't heard from Simeon, then you're not going to it means you've passed. So you kind of assume good news here. There's never like a percentages.
Thomas, can I ask one question by the time people join?
Yeah, go ahead.
So I actually asked in the Slack channel, right? That the fork versus the branching of the main. Actually, I'm super confused because I want your take and not just from the DSI point of view as a developer, right? We always go to there is a branch, whatever you call trunk or main developer, and you branch off that. So this fork concept, I only know in the open source world, but the real projects, this fork concept, I don't know, I'm a little bit lost there. That fork concept. I mean, I know what it is, but like branching off, right? So
Yeah, so think of the fork as like making a copy of the repo for yourself, right? In a space that you can work, right? Versus a clone, which is about bringing the contents of the repo into your local workspace. The two things can feel relatively similar, right? You can fork something and then you bring it down into you clone that fork down into your space. But you can also just clone a repo without forking it, right? So now when it comes to U of T and DSI, right, you all don't have permission to like edit the contents of the DSI repos. But if you were a developer at, Job ABC, right, and you had, your team was working on something and you were brought on to continue to work on, you might be cloning that rather than forking it, right? Or making a branch and then working on your branch and doing a pull request that way. Hope that's clear.
right. So in this case, when we clone your SQL, right, that is only read only. So we should not branch off or whatever. Just read
Right.
only for the repo one. The fork is where we submit do all the assignments, yada
Yeah.
yada.
Yeah.
Uh,
Yeah.
okay,
Yeah.
that's
Yeah.
because probably the DSI, the repo, we don't want like create a PR and merge. So you corrupt the
Exactly
DSI
right.
repo. Just
Exactly
keep
right.
it clean for the
Yeah.
rest of the future. Is that the reason? Okay.
Yeah. 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 Yeah.
Thank you, sir.
Yeah. Good stuff. Okay, let's hop into joins here. Okay, so I do feel like we were just a little rushed on the join stuff. So I want to just really kind of go back. And there were a couple of great comments here to me in Etherpad, wanting a more visual representation of the join. So what I want to start with, I want to go back here first to talk about what we see in this diagram. And I think that this diagram, like quite literally, my very first job, this was like pinned up on my cubicle wall in 2013, right? And I had it for a job or two, and then I think eventually it made its way into the garbage. But it really did kind of help in the beginning. And I was thinking about, okay, how do I make this also, easy to see in a data, like in a table perspective? And so I've done this just for you all today. And then what I've done is I'm going to come to Excel, even though I'm not a huge Excel person, like, you know, it can create some things. I think here it does a really nice job of visually articulating all of the different join types in a kind of a like little toy table example. So what I've got here, and just focus here on the first 10 rows here. I've made two tables here. So I've made an employee table and I've made a Toronto postal code table. And I have 4 employees, Thomas, Niaz, James, Laura, and I've given all of us a postal code. I don't actually know where Niaz, James, and Laura live, so these are probably wrong, but let's just assume that they are right. And we have our Toronto postal codes, and this is actually very much this is the same data that you see in the postal codes table in the farmers market. The postal code table, if you haven't looked at it, it's actually got a lot of like census information. I built it to be kind of Toronto specific so that we would have something that we could all kind of like get a little familiar with here. But essentially, it's just these three-letter postal codes. That's the first prefix, right? And we have some population, and there's a bunch more columns beyond that. But I just want to show this because I think this will help see this. So we have our 2 tables. Let's talk about all of these different joins and what they actually look like when we do this one by one. So take a moment here. We have the 4 IDs for the employee, and we have the 6 IDs for the postal codes. When we talk about in inner join, I think it'd be a little bit too small, Mahi, to split screen it. Let's do this. Let's put this in the Zoom chat. Maybe I can just do this. Let's do that. Be a little bit small, but okay, let's do that. So when we talk about an inner join here, we're going to talk about only this intersection here of matching rows. So looking at the tables, we can see, well, Thomas doesn't live in Toronto. I live in Hamilton, right? So it's not going to match any of the Toronto postal codes. Similarly, these first 3 postal codes, M1L, M8Y, M3H, none of the learning support lives there. So we end up in the inner join only with our matching rows. So Niaz coming to M4H, James coming to M6C, Laura coming for M4M, right? So 3 rows, only matching those 3 postal codes, not Thomas because he doesn't live in Toronto, and none of the employees are in those other 3 postal codes. So that's how we end up with our inner join here. So our center one here, right in the middle. As we scroll down here, let's talk about our left join. So our left join here, our employees table is on the left. So our code here would be like select star from employees, left join, Toronto postal codes or whatever it is, postal codes on, and we're doing, postal code equals postal code. So what are we left with for the left join? So this is our top left one right here. So we have 4 rows. We are matching those 3 that were in the inner join, right? This makes sense because look at sort of the diagram. The inner join was 3 rows, right? So we already know that this is always going to be 3 rows. So, okay, now we're talking about this space labeled A for our additional row here in yellow. Yellow's kind of ugly, sorry. So what is our 4th row? It's me. It's me because we're starting on the left, and there's no data around the postal code for Toronto postal codes, but we're still capturing the information that was in the employees table, the first 3 columns, about me, that I'm employee number 1, that my name is Thomas, and I live in LAP, right? But all the other things here were producing these null values, right? So the left join can never go beyond the number of rows present on the left table. I like that thinking a lot. I think for two tables, I think that's likely to be true, unless we do something really quirky. I think that's a good, solid, true statement there. Okay, let's keep going. Let's talk about the right join here. So just scrolling down a little bit, I'll clear my drawings. Okay, so the right join. The right join here, now we're coming to the top right here. So the right join, 6 rows. Again, just like the inner join, we're going to have matched those middle 3. There's my drawer. Yeah. So we're over here. Again, this was 3, right? The middle box is always 3 rows, right? Because that's the matches of M4H, M6C, M4M, right? Because that's Niaz, Laura, and James, right? James and Laura. So we get those 3 rows. We don't get Thomas because we're talking about the right here. Thomas, we're not going over to Thomas here. He doesn't live in Toronto, so he's not included in this table. We do get no employee data from the M1L, the M8Y, and the M3H. So these are our null values, but we get all of the contents that is in the right table about those postal codes. So they're in Scarborough, they're in Etobicoke, they're in North York, here's their populations, right? So there's our right join here. So this one was 3. This one was 1. Let's get to our very last one here, our full outer join. I bet you guys can do the math here to know how many rows it's going to be. It's going to be 1. Sorry, I drew right on the line. It's going to be 1. It's going to be 3. And it's going to be 3, right? So a total of 7 rows. Again, we're going to match all of the rows across, right? So we're going to get all the things that matched in the inner join, right? We're going to get what was on the left, Thomas, L8P, with no corresponding match on the right. So we get the nulls on the right-hand side here, but we get the information on the left-hand side. We're also going to get all of these rows from the right join, right? Which was these rows. So you can see the outer join is now kind of putting together all of these. We have the combination of the left join and the right join, which are in fact a combination of the inner join, right? And then things to the left. Ooh, Kevin, we'll get to that. We'll get to that. So these are our 4 join types, our simple join types, right? So our inner join, our left join, and our right join. What about these last 3 that I haven't drawn on yet? Right, so talking here in the icon, talking about these 3. How do we get these 3? Okay, let's come over. I'm going to go over to same things here. Okay, exact same thing here. I call this more advanced joins, right? Okay, look at what this criteria is. And I know this image is kind of small. Let me like temporarily make it really big. We're talking here about this one, and we're talking about where the B key is null value. Okay, so left join where PC postal code is null, right? So what does this produce? It produces just 1 row, right? This makes sense. Look at the diagram here. Remember, the inner join is always 3, and earlier we said this A was 1, right? So here, now we know this is for sure only 1 because it's just coming straight down. We're saying not this. We're saying not this. So who are we getting? We're getting just me, Thomas, not living in Toronto, so no corresponding postal data, and intentionally excluding M4H, M6C, and M4M, right? So the only row there is me, right? So this is that left join with that postal where that postal code is null, right? That PC.postal code is null. Okay, the one over on the right, it's the same thing, but the right join version. So 3 rows here, talking about this one, 3 rows again, excluding the M4H, M6C, and M4M matches. And so what we're doing is we're getting the rows that no one is in, right? So no one lives in M1L, M8Y, and M3H. So no corresponding employee data. So here's hence why we're getting the null values there, right? So again, we've taken out that inner join here. And very last one, this bottom one, this is sometimes called the anti-join, right? This is the exclusions in both of them, right? What is in A, what is in B, but what is not in A and B together, right? So our full outer join where PC postal code is null or E postal code is null. So what do we get? We get a combination of these tables here, right? So we get Thomas not living in Toronto, so no corresponding postal data. And we get all the postal data with no corresponding employee data, right? So I hope that helps. Can I share this Excel? Yeah, I will. I can. I'll put it on GitHub. We'll plop it into like the live code section. So yeah, awesome, great thinking. Putting the suggestion to put this guy here too. I appreciate that. Let me just hit save here. So okay. So I'm glad, I think that feels like a nice visual representation. I appreciate the feedback yesterday I got that we needed a little more join conversation here. So let's hop back also here into slides, finish up our very last section from slides 2, which is about how we get to multiple tables. So more than one table can be joined. We've just done 2, right? Just this whole time. So we can select star from table 1, and then we can select our table 2 join type, join them on the key, right? And we can just keep going. We can now have our table 3, pick the join type. And look, we can pick where we want to join the table 3 key. We can either join it to table 1 or to table 2. It's just whatever we prefer, right? And onwards, we can do this n times, right? As many times as you want. So it's really important. The order and type of the joins will have significant effect on the table, right? So it is really important, and it sometimes takes a little bit of like debugging and like experimentation a little bit to determine which table should be your from table, right? It's kind of like your root, and as you start to build around it, it gets really hard to like change what was in that root, right? So I have to experiment a little bit about that. Think about scenarios where the different join types, especially what we just talked about, will result in significantly different outputs, right? So for example, if we start with an inner join between 1 and 2, that means we have significant restrictions on what any join to table 2 can be on later. So if you have table 3 joining to table 2, but table 2 was joined on an inner join to table 1, whatever wasn't brought through by the inner join will be missing, right? So just kind of have that in your head. Think about that's where it's really important to pick the right from table to feel out how to like kind of arrange these things. Okay, let's write some code here. Okay, I want to start again with what we were working on. So we had this. This is in our inner join here, where we had this customer ID originally, and it was like really kind of, it's like the problem is here, the customer purchases table is just only filled with IDs, right? It's product ID, it's vendor ID, it's market date, you know, all these things, right? So we want to oh yeah, you should grab this code from the repo. It's in the live code. I'll put it in the code share, but do that. It is in the repo afterwards immediately. So okay, anyways, going back to this. So what if we want to start to get rid of some of these ideas and actually put like the real values associated with them? So not product ID, we want to know the name of the product. So that's where we're going to start to build out our multiple table joins here, right? So let's start with this one. It's just going to be a nice, you can bring the same question here, come over here. So which vendor has products sold to a customer, and which product was it and to whom it was sold? So, okay, we started with our customer purchases, and we replaced our customer ID here with the customer first name and the customer last name. Well, let's keep going, right? Let's, we currently have three things, right? We have the vendor ID, the product ID, and the customer ID. We've replaced the customer. Let's do another one. So we're just going to add on another one, add inner join our vendor as V on v.vendor, cp.vendor ID. These are interchangeable, by the way, equals v.vendor ID, meaning you can do v.vendor ID equals cp.vendor ID or the other way around. It's not going to matter. Now we have access here instead of this to come in and to get the vendor name. And our last one here, going to join our product as P on cp.product ID equals p.product ID. So here we've done 4, right? And we can go and we can take out our corresponding product ID here and we can do our product name. Sure, we get our comma in there. Nice. Now it's so much more meaningful, isn't it? Right? Let's put our market date on. So we know on this day, Jack bought habanero peppers from Marco, right? Marco's Peppers, right? So we start to fill out those IDs a lot better. By adding market date here, we added a lot of rows. Let's talk about that just for a second. Remember, we're talking about sort of the distinct notion yesterday. Without market date, we were 200 rows. So we were some combination mathematically of customers buying products from the vendors. However, it's like, you can think of it like however many products the vendor had times however many customers bought that times however many vendors are there. So it comes out to 200. We would have to know the exact numbers to do it, but we could, right? And by adding the market date back in, oh man, we're saying a totally new thing, right? Let's make it a new query. Just copy the whole thing. And let's add the market date back in. What if we add the dates they were purchased? Okay, let's pop that one into the code here. Yeah. Okay, we put our market date in here. We have 200 rows originally. Let me just make sure I have my comma. And now, wow, we have 3,371 rows. Okay, it makes more sense, right? It means that Jack has bought habanero peppers from Marco several times, or likely Jack. Maybe we have to like visually confirm that it was Jack, right? Can't make any assumptions here. Maybe we got to add like an order by or something, right? Order by what? Customer first name, customer last name, market. Let's see, and then let's do product name. And let's do market date last. Currently, it's like default ordering. Default ordering is like kind of a little bit of a guess. Like there's no guarantee you'll know exactly what it's ordering. So sometimes it's good if you want to order by things, like do it explicitly. Okay, we'll just stick with Abigail here. Abigail's bought Annie's pies how many times? Like a lot of pies. She's bought 12 pies. It's over several months. Like she's not, going crazy, right? So, and yeah, it is ascending by default here, right? We ended up with Abigail on top and Annie and apple pie on top. Made sense, right? I saw a quick question there about can we talk about the aliases again, right? So this is that as CP. So we're just using this so that we don't have to refer to customer purchases as customer _ purchases in all of these instances that we have CP. The benefit of that, let me go back to the inner join query. We did it the one time without aliasing. Just here at the top, this very first one, right? You see in the join how we have this like much longer join clause. It's because we didn't alias. We can just instead alias this customer purchases and alias this product. And we have to do the same thing in the select statements, right? If we're going to refer to a column that's in multiple table to avoid that ambiguous error, right? We're going to have to we're going to have to like make sure that we have put the name of the table that it's coming from. Well, that's quite long. And if we were using fully qualified, database.schema.table, wow, it'd be really long. So we want to alias. It's a lot easier. So cool stuff. Okay. Let me put this, let's put that bottom one in here. Okay. What questions do we have about, before we hop to slide 3, what questions do we have about joins? Anything else we can touch on? No? Okay. Okay. Good stuff. We're going to write, Sad, you just have 2 semicolons there. We're going to write lots of joins from now on, right? Because we're never going to refer to just single tables, right? We see the value immediately of, when referring to the customer purchases, we actually really want to know people's names, what products they are, who the vendor is, something. We want to know more information. Nobody wants IDs. The IDs are what SQL wants to work in the back end, right? Okay. Okay, hopping to number 3 here. Okay. 627. We'll look at when it makes sense to do the break here. Okay, we're going to hop to number 3 here. We're going to talk about aggregate functions and subqueries, temporary tables, CTEs, and then hopefully we'll have time to talk about datetime functions. Okay, so when we talk about aggregation, counting, summing, averaging, aggregations. When we talk about that in the context of SQL, in the context of the sets, the results, right? We want to generally require them in a group. So we need this command, group by. Group by is mandatory. Anytime a column aside from the one is aggregated is present. Aside from the one being aggregated is present. So for example, a query where we want to know the number of days in each month, we have a calendar table, and we want to produce January, February, March, so 31, 28, or 29, right? 31, 30 onwards, right? What we do here is we're going to count the number of days, and we're going to make a group on the month, right? So that we produce that value. Where's my pen? Right, January 31. February, whatever it is, 28, March 31, right? And we do this by including this group by. So all the things that are not being aggregated, it's our count that's being aggregated, have to go in a group by. Well, the only thing that's not being aggregated is groups, or not being aggregated is months, right? So that's what goes in our group by. Group by, it comes after the where clause. And when we do aggregation functions, it's going to be calculated per group. So if you have multiple groups, it's going to do the calculation on each of them. Our first one here, our first aggregation, the simplest is count, right? It performs count of any given columns or set of columns, right? We have one really easy one here. The easiest of all the aggregations is count star. So select count star from table. This will give you a count of the rows for any given table. You don't have to have a group by here because there's nothing to be grouped upon. You're just saying count everything, right? Multiple counts are treated as separate columns, right? So if we have, again, our calendar table, and we select the count of days and the count of the distinct months and then the years, we'll produce 3 columns here, right? The first will be the number of days, so 31, a count of our months, 12, and the years, 20, would be 365 rather, sorry, 365 12, and then 2025. 2024 was a leap year, so we'd have 366, 12 months, and 2024 as the year, right? So we're putting that in the group by. So here we're introducing the count distinct concept. I mentioned yesterday with our distinct that you could place it both at the beginning of the query after select and also here within the count, right? So what's it doing? It's saying, okay, let's make sure that we count just how many distinct objects there are. So count only those unique, with distinct, only those unique values are counted. So if we do on this table a select count distinct on the product ID, we're going to produce a different value than count of the product ID in this table context, right? Because distinctly here, we have 1, 2, 3, 4, but just as counting, we have 1, 2, 3, 4, 5, 6, 7, right? So our count of distinct products, 4 for vendor ID 1, our count of products, 7 for vendor ID 1. Our grouping here, right, would be that vendor ID. So let's do some counting. Yeah, at the top here, I'm going to put multiple table. So I add that to GitHub for you guys later. Okay, counting. So just as we said, let's count the number of products. So easy one, we're going to go to the product table here. So select from product. And sure, we can do count and then our product ID. You could also do the product name. Could result in a different value if you were doing distinct, possibly, just depends. Not in the product table, not very likely, but it's feasible, right? So just think an ID is probably better to count if you want something like a counted product. So great, we get 23. We can visually verify this pretty easily. We go over to the browse data table and we just see that there are 23 rows, and we already know the product ID is the primary key. So we know it's unique, right? So we know there are 23 products. That makes sense. Very straightforward. How about how many products per? So per something. That means we're going to introduce this grouping. Let's do our product QTY type. So let's look at our product table first. You guys can kind of remember what's in there. Okay, so we're talking about here the product quantity type. So it's either pounds or unit. So habaneros are measured in pounds, but poblano peppers are measured in units. Sure, whatever. So, okay, we're going to do our same thing here. We're probably going to do we're probably going to want the value first visually, or the column that we want, the product name that we want visually. That's the word I want. So the product quantity type and then count of the product ID. So this is going to say how many are measured by pounds and then how many are measured by units. We need our group by, and it's going to be our product quantity type. So this is per, right? The idea of like something per, right? Oh, perfect. We also had null in there. That's great. That's okay. Let's go back and look real quick at the product table. Yeah, we had those red potatoes. Oh, I just took that null out. All right, undo that. There we go. I just took we have these null values. So actually there were 3. We had units, pounds, and unknown, right? This missing value. And sure enough, that is what we get here, right? So select product quantity type, count the product ID, and then this group by. Do we need to assign column name to count? Yeah, let's definitely assign a column name. Thanks. I appreciate that. This is like num of products, right? This is still the same, right, as num of products. Something like that. Agreed. We don't really like this count name there, right? That's not really a product name. That's not really a column name, right? Be hard to refer to later. let's add another group by so that we can see sort of this effect of having multiple group bys. So how many products per product QTY type and per their product size? So select, let's do again the select star so we can just see it. So we know what we're talking about with the product size. Okay, so our product size, small, medium, large, 8 ounces, kind of lots of things, right? We got medium a few times, we've got pound a few times. So we're going to get a lot more rows out of this, right? So product size, product quantity type, and our count of product ID as num of prod. And sure, we need our group by here. So product, we can just grab the product size and the product quantity type. This is a pretty typical thing. We could type it out too. Just place it here. These are all the non-aggregated columns, right? Yeah, okay. So we get a lot more variance here, right? Let's find those mediums. So there are a total of 5 mediums, but some of them are in pounds and some of them are in units. So you see how medium has been split out because we have these multiple groups here. If we just had asked for a count of product size, we would have mediums be 5, but because we added this additional grouping layer, we get medium and pounds or units, right? And we get that broken out. So a lot more rows there. All of this, if you sum up all of these number of products here, if you put all those into Excel, it's still going to be 23, right? We're not excluding anything. We haven't filtered anything out. We're just kind of we're just counting into categories. Let's do one more here with count distinct. So how many unique products were bought? So we can't go to the product table and do something unique. Everything's like already probably pretty unique. So let's instead do it on our customer purchases. So count distinct product ID from our customer purchases. Here we're placing that distinct inside the count. Okay, so 8 products have been bought as bought prods, right? We can go visually verify that. We can go scroll through the 4,200 rows and we can visually verify that's true. We could also run a select distinct on the product ID and we'd also get 8, right? So lots of ways to kind of see that we get to 8 out of it. So let's count. Pretty easy, pretty straightforward there. Put that in the code sheet. All right, on to sum and average. Okay, sum performs the sum total of any numeric column. It has to be numeric, right, to do sum on. I want to say be a little bit wary. SQLite may be more permissive for columns with numbers that are not explicitly called an integer. It's best practice to use this cast command to say that these things are numbers before summing them to ensure the validity of a column, right? Essentially what you do is you say like cast the column as int, and if something wasn't an integer, it's actually a good thing to err. This isn't an integer. I can't make ten an integer. It helps you like fix something upstream, right? So it looks like this cast, and then the sum is on so I think this one is always backwards. I think the sum goes outside of this. Yeah. I think you can do it both ways here. Maybe slightly different results here. This would be anyways, the point being you want to make sure that you get the integer things as integers, right? And make sure that you again, going back to kind of that control. If you have a well-designed database, you don't have to worry about this as much. But if you don't have that kind of ability to control how something's flowing in, just to kind of make sure that you have specified that you really want this to be an integer, right? You can accommodate multiple columns using the plus operator. So sum of column 1 plus column 2. If you're thinking, what if I wanted to do a sum and a count simultaneously? This is like a rolling total. We'll do that next session. So not something that can be accommodated explicitly like this. There's other ways to go about that. Just like sum, we have average. We'll do these two together because they're just like so correlated. Average just performs the average of the numeric column, right? It can accommodate multiple columns, just like sum can. And both of them can also handle other mathematical operators, not just plus. We can do minus, we can do multiply, we can do division, we can do modulo, whatever you may want. This is a typical interview question and kind of a gotcha. Sometimes your source system already has done an average on something, and you want to be careful. Don't average an average column when using group by. So let's imagine that we have here our market average temperature stored in our market date info. We've got our days of the week and our average temperature. If we group by the market day, so we've done a group by here, we can produce an average for each day of the week. So for Saturday, 36 and 28 and 29, and it averages to 31. For Sunday, 33 and 31, averages to 32. And what's to Wednesday? Now, what we want to avoid, since we've already done a group by on this, you do not want to do an average of these values. If you do an average of 31, 32, and 28, you will actually get a different result than if you had done an average of all of these 7 values themselves. So just make sure that you're cautious of what could already have been aggregated and averaged, right? Always better to go back to your kind of raw data rather than something that's already been pre-computed, right? So it's just an interesting thing how that can happen. So let's do some sum and average coding. Okay, let's do like how much did a customer spend each day? This code we're going to write a lot of times. This little snippet, right? Okay, so we'll do a select of the market date for our day. We'll do the customer ID. And we do from, sorry, help with the customer purchases. And then we're going to do a, let's look at it first. I'm sorry, we should just look at it first. So we're going to use market date, our customer ID, and to get the notion of what a customer spent, we do the quantity times the cost to the customer per quantity. So 2.18 times 6.99, whatever that is. That will be our total spent, right? And we're going to sum this across all of those groups, the days and the customers. Let's do this. Let's put our market date and customer back in there. So we're going to do sum, and we're going to do across these two columns, just as we said, quantity times cost to customer per QTY. Close the bracket as total cost. And we do our group by on market date and customer ID. Okay, so customer ID number 3 on April 5th spent $4. Let's actually go look at this. So talking about customer ID on April 5th. I'm going to come over here to the browse data. Customer ID number 3, 2022, April 5th. Okay, so Talking only this row, not the rows below, 23, only this row, 1 times 4. And sure enough, we got 4. It's kind of a boring one. Let's see if we can do customer ID number 5 instead. Ah, better. Okay, right. Customer ID number 5 bought 3 times 4, which is 12, and 1 times 18, 18. So 12 plus 18 as we do the whole grouping, right? Because we're not grouping, we're not including vendor ID here, right? Or product ID. We're in our group by. We're just looking at our customer, right? So we're going to get 30 there, right? And sure enough, we do, right? So those two rows were aggregated together, right? Making sense? Let's do an average real quick. How much does each customer spend on average? Let's not do the exact same query. Let's just mix it up a little bit. So we're going to do our customer purchases. And we can do our customer ID. And we would do an average of our, sorry, I forgot my comma. Our quantity times cost to customer per QTY. What I do here? I forgot my group by. Right? Group by customer D. Okay. Oh, it's hideous. It's hideous. Why is it hideous? Let's like make this a human, right? Let's round, right? Let's round, and the round function returns a floating point value, X rounded to 0 digits to the right. So we just listen to what it's saying and we say, okay, I want to add a comma here and we want to round to Y digits to the right. So comma 2, so that's just rounding as average cost. What happened when I didn't group? SQL was like, there's no group. What do you mean? So it just like gave us kind of nonsense, right? We had to have the group. Okay, let's say this is good. Customer ID spends $14.35 every time they go to the farmer's market. But who is customer ID? This is so boring. Let's make this more interesting. Add an inner join, right? We're thinking about humans, right? Customer. Let's alias these as CP, as C. And we're going to do on C.customer ID equals CP.customer ID, because that's the primary keys, right? Primary key, foreign key. Now we don't want customer ID, we want customer first name, customer last name. Now, interestingly, customer ID actually represents the row because it's the foreign key here. We actually don't have to change this to customer first name, comma, customer last name. We can just use customer ID, even though it's not present in our select. But we do need to alias it. Why do we need to alias it? Because we still need to specify which customer ID we mean. It's an inner join, so it's okay. You can just pick one of the other, C or CP. Oh, so much more interesting. Alejandra Costa, she spends $14.35, right? So much more meaning when we get that inner join in there, right? So we're combining lots of things here. Average, round, group by, inner join, right? And we're getting much more meaning out of this. How much does each customer spend on average when they visit the farmer's market? Pop that into CodeShare here. Oh, it's our old one. Okay, let's talk about min and max. Can I re-explain round? Yeah, let's re-explain round. So round here. Round is saying, when we pop this up here, it's saying, what is the floating point value that you want rounded? So for us, that is our average value right here. That's our floating point value, so a decimal value. And if we provide it X, we can also provide it Y, and that's the number of digits to the right of the decimal, which we just did a comma 2. And we put this around our value, right? So We're saying round the average by 2, essentially, right? 2 decimal points, 2 points, something like that. Kind of verbally concept, right? We do that with a comma here. So just taking advantage of another function interlaced together. Zena, hand up question.
Yes, I have a question. When we have a group by, we should group by the table which we have it in a select statement. It's like you have a like customer first name and customer last name, but in a group by we have like customer ID.
Yeah, so in this case, because customer ID is serving as the foreign key here, right? We actually do have the ability to say that, you know what, customer first name, customer last name is a given person here. And we don't need to group it by the last name, by the first name. We can just represent the whole row there. So it's actually kind of a tricky thing, right? If you had customers' last names with the same last name, the same first name, something like that, you wouldn't actually want them to aggregate together. You would want it to break it out by the customer ID instead. It doesn't have to be in the select statement is kind of the interesting thing about it.
Okay, thank you.
Yeah, good question. And yeah, Victor, we can use the concat absolutely to do that. But I think easier to just do it with our customer ID knowing that. Okay, min and max here. Good question. Very straightforward as they sound. Min takes the single minimum value of a given column. Max takes the maximum. You should be a little bit cautious of like combining min and max with other aggregate functions like sum and average. Like you don't always get the right things out of them. Just like sometimes do the math yourself, right? What do you guys think? Just write in chat here. What do you think what happens if you do min on a string? You get an error, you get something else. What about max? Any thoughts? But yeah, I think Kirby I think's got it here. So min, right? We're going to actually say what comes first alphabetically, and max what comes last alphabetically, right? Not particularly useful, but something you can do if you really want to know who's the first or something like that. I guess it's a way of doing it. Lots of ways to do that. Yep. Yep. Mirroring that ASCII value. Exactly right. Okay, let's do a quick min and max. They are very straightforward. Min and max here. Okay, how about what is the most expensive product? Okay, so select, let's say from our product. Our vendor inventory is actually where we have our original price. So we're going to join to vendor inventory so that we can have the name of the product and our cost of the product, the original price, right? So inner join vendor inventory, VI on p.product ID equals vi.product ID. So let's, like we said, we'll do our product name, have it be meaningful, and our max of the original price. There we are. Pretty uninteresting. I want to say, I know, having done this, it's worth looking at. We browse the table for our vendor inventory. You'll actually notice here, as we scroll through the product IDs, 18 is the price for both 7 and 8. Yet we only got apple pie, which is 7. I think it's 7. Yeah, but we didn't get 8, which is cherry pie. So it doesn't handle tie-wells. Max is like a sledgehammer. It just gives you an answer, but don't expect any nuance. So just have some cautious. Why it picked apple pie over cherry pie. We might think maybe it was because of the A. It's kind of nebulous. It's like some default ordering in the background's happening. We can't guarantee this. This is just sort of the outcome of Max, right? Not particularly interesting, but good to know that Max might not always be, if you want to have a little bit of nuance, you're going to, in this case, just get an answer, right? Let's do the minimum price per each for each type of the unit and pounds. What was that? What was it called? It was like unit type or something like that. Product QTY type. So we'll grab the very similar query here. Just grab the whole thing. Get rid of our max. With the same construct for our inner join and our from here. And let's add our product QTY type. And let's do our minimum on the original price. And yeah, we should, most expensive, right? Be naming these columns. Let's put the group by in here. So group by our product quantity type. Okay, so the least expensive unit is a poblano pepper, and the least expensive pound is a jalapeno pepper, right? It's kind of hard to verify. You have to like build the join, not do the group by. So you could do it though, right? Take this out, take our minimum out, take our comma out. Put our original, let's keep our comma in. Just put our original price back in and like visually verify this. We want distinct. Good to know how you sort of debug a question like this. And we want to like order by our product QTY type and our original price. Our answer was jalapeno peppers and poblano peppers. So yeah, okay, we can tell that it worked. Again, it didn't handle the tie well between sweet corn and poblano. It picked one of them. But you see how I kind of got to the debugging of these are the two rows that we got. We were able to like humanly do this by taking out the aggregation and sort of like go and do it. And by putting the aggregation back in and their group by back in, and kind of get back to just those two rows. So good to kind of understand fundamentally what's happening by having not having the aggregation, right? That's how we kind of prove it, right? To a certain extent. It's like put that in there. Prove it. Just take that. You guys can play with that later, right? Sort of like manually, just what we ran again, right? So it's in there. Min and max, fairly straightforward things, but a little bit like a hammer. No, they're like a hammer. A little bit of arithmetic conversation here. SQL can perform basic complex calculations, addition, subtraction, multiplication, division, power, geometric and trigonomic functions. And they can be useful like we did by combining them with aggregate functions, the multiplication inside a sum, for example. We did that like that total spent. That's what we did immediately. SQL is similar in other programming languages in its kind of inability to handle floating point values. It sort of manages, but may have some rounding issues. It just means that when floating points are aggregated together, it doesn't always like do the rounding exactly right. You'll see like little like 0.33 times 3, and it'll be like 1.00000004. You'll be like, where'd that 4 come from? It's just how the floating points are dealt with by computers. Let's think about this one for a moment. Because columns are type specific, If we wanted to perform what we call integer division on two numbers, how would we go about doing that? Does everyone know what integer division is? So like, if I do 10, if I do 3 divided by 10, right? We get like 3.33, right? All the way. But we also have this function, right? That's integer division. That like maybe when you were like young, you learned before you learned long division or more complex division, right? Where you did like 10 divided by 3, but you wanted to get like 3, and then you got this like remainder 1, sometimes how it's articulated. Elliott says the modulo. So the modulo isn't the integer division, it's the remainder. 10 integer division 3, 10 mod 3 is 1, right? So how do we get the 3, the integer division? The hint here is the type specificity. So we can tell SQL, force 10 to be an integer, force 3 to be an integer, force the outcome to be an integer. We can use that cast to say, cast this 10 divided by 3 as an integer, and we will produce 3, no rounding, right? We'll get that integer value. It's useful. Integer division and modulo are super awesome programming tools for looping functions. It's a great way to like iterate things by rows, for example. So think about integer division and modulo like buried in the back of your head. It'll be useful for Python, I promise. Would it be better to round? It's just a different function. It's just a different function. In some programming languages, you can do this, 10//3, and you'll equal 3. If you know Python, go type that in, you'll get 3. So it's a little bit different than that. Yeah, so we can coerce them, right, if we want to get that. Okay, let's look at some live coding here for our integer division. Wait 1 sec. I lost my place here. There's not many meaningful, there's not as many meaningful examples here on this one. I think the one that we have done nicely. Here, I'll just prove this integer division concept here. 10.3 divided by 3.0 as division. 3.33, right? But we can also do cast 10.0 as int. When we do 0.0 here, guys, this tells SQL this is a decimal. This is useful. This is useful. Sometimes you want to make this a decimal, right? You say, I want to do 10 divided by 3. So cast 10.0 as integer, and then cast 3.0 as int. Oops, sorry. This will be our integer division. Integer division. Right, now we get 3, right? So cast. Cast is forcing something into a different, into a specific type, right? So casting it as an integer, casting it as a decimal, right? Casting it as a string, but it's not very likely that you're going to cast like an integer into a string, for example. Can you force SQL to format numbers with commas for thousands, for example? Yeah, I think you could have some, yeah, just from like a visual output perspective, I think you could get clever and do that. Yeah. I don't know how to do that off the top of my head. That would be like a good, Google. Let Stack Overflow answer that one for you for sure. What about, I mentioned like power, for example, just know these things are here. So, 2 to the 2, right? 54, pi, just all these math functions. I actually have used some of these math functions in real life when I was doing some consulting work for this York Region Transport, up in like Markham, Thornhill. And we had this really cool like SQL program that when the buses were going through red lights, they had this like ability to, as it was approaching the red light, they could like have this radio signal sent out to say like, no, stay green longer rather than or turn green. So the bus didn't have to stop. Like this was along like Highway 7 if you've ever been up there. So we did this like with some trigonomic values essentially to like take the distance here of sort of like diameters of circles because you could be coming from multiple directions, relative to like geometric, coordinate positions. And actually it was like, kind of a cool way to like interact with some of these more kind of complex, like real world trigonomic or geometric ideas, right? To say like, this is the distance that it is depending on the angle or wherever it's coming from. So it was a super cool one. It's like one of my absolute favorite ones. But yeah, the idea was like, here's like a real world use case of like a bus is approaching a green light and it's a dedicated bus lane and it doesn't want it to go a red light. And so you have this radio, communicating to another radio, on the stoplight and saying like, no, stay green. And it has to know how close it is, right? So there's sort of some like math. And we'd look at like how often it would work, right? What like the percentage was, how hard the buses would hit the brakes afterwards, whatever it may be. It was super cool. Okay, let's get to our last aggregating function here, which is having. This one's super important here. Okay, where clauses filter rows before aggregation occurs. So this is important. So if you are going to have a set of rows and you're going to add a where, you are eliminating the set of rows that is not in that criteria, right? Having clauses allow us to filter the rows after the aggregation is calculated. So the way it works, having comes after a group by, but before an order by. And what it does, having is filtering aggregated calculations. So it means you can have both where and having, but that these things are not interchangeable. For those of you who are interested in sort of the execution order of things, I recommend looking at this slide in just a little bit more detail. I'll drop the image here in chat. This tells you what order things actually run in. It's super interesting. You probably have thought this whole time that your select things happened first, but they don't. They happen fifth. The first thing that happens is the join. The next thing that happens is the where. The thing after that is your group by, which then the thing after that is having. And then we do the select. So that's actually why we were able to do that group by on that customer ID instead of the customer name and customer last name, is because we're referencing columns that exist in the table, regardless of whether or not they exist in the select statement here. And then finally, at the very end, we can do step 6 and step 7, our order by and our limits, right? Oh, we're going to do some live coding before we do the Mentimeter. That'd be a little unfair. All right. So having. So how much did a customer spend on each day? Let's go back to our, what was it? Our sum. I'm going to grab our sum query here. So this is selecting the market date, customer ID, and sum of the quantity times cost to customer per QTY. Okay, let's talk about the difference here between where and having. So where, if we want a where statement, let's say where the customer ID is between 1 and 5. So 6, 7, 8, 9, etc. aren't going to be here on the in this result set. So we had 2018 rows. Now we have 564 rows. Okay, We haven't done anything different than you guys have already known, but let's do something different. Let's filter the total cost row. Let's say we wanted to do more than 50. We can't do this in the where clause. We can't say and total cost is greater than 50. We get an error here, misuse of aggregate sum. Because go back to that execution plan, where happened before the group by happened, before the aggregation happened. So there is no such thing as total cost. We don't have total cost. So this is why we do this afterwards with a having. So having our total cost is greater than 50. So two different functions here. So this is filtering the aggregated values. And this is filtering the non-aggregated. Obviously, we don't have to have the where clause. We don't have to have the having clause, right? But we had really different values here. We originally we were like 200 some rows, right? And it's filtering these grouped by records. Yeah, this summed record, right? So it's very crucial. You're not going to put your customer ID between 1 and 5 in the having clause either. These things aren't interchangeable here, right? Do another one. Let's write another one. How many products were bought? So we'll do a count instead. So select from our customer purchases. And we'll do our product, we'll do a count on the product ID as our num of product. So what we did for our first counting, right? And we'll do a product ID, right, for our group by. Right, so big numbers here. Product ID number 1 bought 175 times. Product ID 7 and 8, the pies bought 500 sometimes, right? So let's do a having on the count of the product ID between 300 and 500. So we're going to get, I don't know, this one, 3 and 8. Cool, yeah. Whoops. What did we do? What did we do? Oh, missing a semicolon. Yeah, 3 and, oh, 16. I think I read the number wrong. What if we want to do the where clause where our product ID equals 8 or something like that? Greater, let's do greater than 8. And less than 8, less than or equal to 8. Oh, where product ID. So we see the difference. We only get that less than 8 for 3, right? Can we do another where clause after the group by? No, yeah, as said there, we would add more, we'd add more here, or customer ID equals 10. Something like that. We just have more there. Let's do our quick Mentimeter and then let's take a break. Should we have done it the other way around? I want to filter a query based on an aggregation here, which is correct. Yeah, we should have definitely done it the other way around. As you guys take the break, think it through. Nice work, nice work. Lots of people coming in here, right? So it's our having clause, right? That does our filtering on the aggregation, right? Good stuff. All right, let's put that code there in our code share. Let's take 10 minutes. I think I missed putting the arithmetic in there too. Wasn't really much in there, but if so desired to play with later. Yeah, let's take 10. See you guys at 7:25. Alrighty. Hope everyone's making their return here. Jumping into our next topic, subqueries, temporary tables, CTEs, getting into fun thinking here. Okay, so thinking about subqueries here. SQL allows us to query the results of another query, and we call that a subquery. They can be placed in two spots here. Subqueries can be used in the join or technically the where clause. And if you are talking about it in the context of join, it can also be in the context of from, right? So in that case, it means you want the subquery to add columns to your output. And the reason that you're doing it is you're using that subquery because you're joining or selecting complex criteria that requires some manipulation itself. And it's often the case that you're joining two or more tables, like within a subquery to another table. So sometimes you're like making a join together of two tables to join to a third table or something like that. And that there's things that are sort of like dictating or needing to be kind of grouped in this kind of sensible way. When we talk about this, I'm going to talk about sort of our the inner query, the subquery versus the outer query, right? So just visually here, sort of the subquery is the things here in this kind of yellow versus the outer query, which is sort of like these things here in blue, which span around that subquery because it's being placed in the from or inside the join, right? Don't get too worried about like the row number component. We're coming to it. Here's like a good example, one of the most common examples of unneeded subquery. The other context here is the where clause. It means that you want to filter the results, and you're using the subquery because it's just simpler than joining or filtering out the columns otherwise. Sorry, I'm about to see this, perhaps? No, okay. It's important to note here that when you do this, you really tend to be only to return, you tend to only be able to return a single column out of this from the subquery. Why do you guys think that is? Why can you only return just one subquery in this case from the where? Just write in chat if you have thoughts here. This is different from the use in the from or the join, where you can bring as many columns as you want here. Here we can only select one column here, right? I think so. You maybe on the right track here. So right, we're setting it equal to something, right? Yeah, it's in the context of that where clause, right? So yeah, the where is to another column, right? Like where this column is. So you want to filter that market date, right? So we can return more than one value out of this. So all the days that it has rained versus each day that a sale has occurred, for example. So we're filtering down to all the days that this rained, right? But yeah, we're kind of having this where market date. We want to select the market date value so that market date equals market date, right? And if we need more, sure, and or whatever it is, another subquery, right? If you're really advanced, I learned this myself. You can think about tuples in this context. If you don't know the word tuple, don't worry about it. Yeah, in this case, we're getting all the days that it did rain, right? In subqueries, for all of them, the columns need to be uniquely named inside of that. And it's good to know that you can highlight, and I've kind of been doing it, but it's good to know, especially in the context of subqueries, that you can highlight the kind of inside that inner query there, and you can run it by highlighting it. So you sort of test things as you go. There's no guarantee for every one of these IDEs, but SQL DB browser does it. So let's do two different ones here. Okay, so first we'll do our subqueries join. So let's do, what is the single item that has been bought in the greatest quantity? Okay, so when we're writing subqueries, our brain, we need to like pause our brain kind of halfway through. We need to say, we need a set of things that we are going to like want to like incorporate or use to filter or something like that, right? And so we're going to write first sort of our construct that we want to make the inner query, so that then we can make the outer query around it, right? So the way we think about this kind of question is like fundamentally, what is it first? It is like a counting exercise first and foremost, right? And then it's going to the notion of the single item. Okay, so it's going to be like an aggregation on top of that, right? So let's do the counting function first. So this will be our inner query, right? Our subquery. So select our product ID and our count of the quantity as quantity. You need to name it here. So actually be explicit and name it. Sometimes I've been lazy. And this will be from our customer purchases. This is the count of things that have been purchased, right? We need our group by, or group by our product ID. Okay, let's run this first. Okay, so this is the quantity that things have been purchased. We looked at this one earlier. We did it with our having clause, right? Because we filtered to 300 to between 300 and 500, right? So we did this. Okay, so now we're saying, how do we pick the highest one? Think about it for just a second. How do we get product ID number 4? Yeah, perfect, max. Okay, but we can't just do max on the count. We need to do it outside of that. So this becomes something that we're going to do as a join. So let's actually do this now. So we're going to say select our, we can do first, yeah, select from, and then we open a parenthesis, and we're going to close the parenthesis on the other side of the query. See how it's highlighted there in blue? It's nice to do. Just tab that in so that it's nice, easy offset. That's very much the standard notation, is to tab that in. See how I highlighted it, hit tab. Okay, couple more things, really important. We need to alias this subquery. We need to give this a name. Anisha, I like your thinking. We can call it X. You can call it Y, you can call it Z, whatever you want to call it. But we need to give this a name. It's an unnamed table. It needs a name, so we alias it. I like X. X is my favorite for that. Okay, so select our product ID and our max on. Now look, we have the access to the product ID and the quantity table, columns in that table, right? So max on the quantity. There we go. Okay, what if we want to make it more interesting? IDs suck. Let's do the product name instead. How do we do that? Let's switch this to a join. Inner join to be explicit. And let's do from the product table E. So now we're going to use the X alias. I'm going to say on p.product_id equals x.product_id. Now it's important here. X.product_id must exist. It does. Now we can go get the product name, and we've incorporated here in a join. Okay, so it was banana peppers that everybody loves. It's interesting, right? Yeah, can we start at the beginning again? Can we think about this again? So we started with the construct of this is if we want to know first what's been bought in any quantity, we have to count. We have to say, what quantity have they been done? And so we have our select product ID account of the quantity from our customer purchases, and we have a group by on that, right? So then here we can see we have created a result set here. And now we're going to say, okay, from this result set, we want to get more information out of this. We want to say, okay, we want specifically only product ID number 4 because it's the max quantity. So we're asking for it to do the maximum on this table as if it's just a table that we had. We're asking for it to do the max. And we're asking also to just treat that product ID as something to join on so that we can get the product name out of it instead. If we don't do the max, let's just not do the max for a second. Let's just do the quantity. Yeah, perfect. This is before the aggregation, right? This is what we just have done a join to the quantity on the product ID, right? But we're able to just treat this result set as something else, right? Something to do beyond that. Yeah, X is the alias for the subquery. This result set, this SQL query, we named this X, this result set. Yep, Michelle, go ahead.
So just quick question. I understand X is alias for inner join, but why in a situation we also want to put the alias P for product?
The P for the product was up here.
Yeah, why we need to?
Oh, so that we can join. So that we can join the product ID inside of here.
Oh, I see. Got it.
Yeah. Okay, perfect. Okay.
So if we don't do that, right, doesn't mean we just need to be like product, dot product.
Oh yeah, we could do dot product instead, right?
Okay, got it. But here we just don't need the S. Because that's different from if you just do a simple query, we just do like product as P and blah, 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 right? So I think that's just a difference. Okay, thanks.
Yep. Ritu, go ahead.
So the count quantity as quantity, like which one you were counting as, alias's quantity, like the entire thing, like product ID and count of quantity?
Yeah, let's go back to the cut. Before we do the count here, let's just look at the quantity. Oop, put it on the wrong side here. Let's look at what we did before we did the count. We had all of the product IDs here. Sorry, we have a group by there. Let me not do the group by. Okay, so we have 4,000. Let me delete all this stuff in the way. We have 4,221 rows. This is just a subset of the product of the customer purchases table. This is all the products that have been bought and in what quantity were they bought. And here we're going to do this counting on the group by for the product ID. So we're just counting how many times product ID number 1 has been bought. So 1, 2, 3, 4, 5, all the way down to wherever it ends. It ends at 174. So product ID 1 has been bought 174 times. Let's run it with the count. Sure enough, it's been counted 174 times as we're going through that. And when I name it as quantity, that's just me naming the column, right? As quantity purchase, if it's easier.
So what product ID is being, why you need to do the group by the product ID? What special thing it's doing here?
Well, because we want to know which item it is. If we don't do the product ID at all, and we just do
grouping by. Grouping by is needed or not?
Yes, yeah, you need it because we're doing for each of the product IDs, how many times were the products bought. So product ID number 1 was bought 174 times. Product ID number 2 was bought 297 times. If we don't do the group by, we would just get 4,221. We would get the sum total of all of these.
After that, when you are ending the parenthesis, X on, what is this X doing?
This X is the alias, the name of this, what we're naming this result set. And then the on statement is related to our inner join that we join to product.
Okay. Okay, making sense now. Thanks.
Good, good. Okay, let's do another one, guys. Let's do it like in a case statement or something like this. Kevin, as is always optional. Kevin points out that I didn't use as here. You could definitely use as. As is always optional. I'm kind of inconsistent on that. I always try to be more consistent on it. Let's just do a subquery and a from statement. Simple subquery and a from statement. So let's do. We'll play with this kind of one a few times. So let's do a. Let's just grab from our customer purchases table. All right, let's say that we're going to introduce inflation into this. And so we're going to grab our product ID, our cost to customer per QTY. Let's do a case when statement here. Case when our cost to customer per QTY is less than $1. These are strings, by the way, because they're decimal values. I think they were saved. They are decimals, but decimals are typically in strings. Then the cost to customer per QTY times 5. So we're going to make all the things that are lower than $1 5 times more. Otherwise, else, we'll just leave it. We'll say it didn't inflate. Lucky us. So end is inflation. Let's run that. We haven't done much, but okay. You can see we have our inflation value here, where we took 0.5, we times it by 5. We didn't do that for 349 because it was not less than $1. And let's just add this as a select statement. Like distinct. And we're just practicing putting this here in the from statement. Have that in here. And now we have access to all of these things. Let's do our product ID and our inflation values. So we're just going to get this distinct value on that. Oh, I forgot my semicolon up here. Oh, no. Oh, we rename that one to quantity purchased. Okay, okay. Yelling us about the top query when we're trying to work on the bottom query. So you can see here it was product ID number 3 here that we increased the value, inflated the value, right? So interesting stuff. Yeah. So just this one's not as meaningful, but we're just putting it in the from statement so that you guys can kind of see conceptually. It can go in the from statement. It can go in a join statement, right? You have access to things that you create in here. You have access to these 3 columns, right? We could certainly rearrange this one without the subquery, but just want to kind of demonstrate that you can put them in both of these spots. Let's look at the where version of this. I gotta fix this one. We kind of debugged this. Let me pop this one here into the code share. Okay, subqueries where. So thinking about the subquery where, right? We're thinking about this example, right? Where we are filtering down the days it has rained or something like that. And we're doing it very convenient to this. We don't have to join market date info to this, right? This is the great thing about the subquery in this case. Let's just write this one. Let's take a screenshot so that it's handy. let's talk about this, why this one works, why it's so cool to do it this way. This is our one we write over and over again. Let's go grab it. It's from the sum query. This one right here. It's on our vendor ID too. This is from your sum. I should run this one. Okay. So we have our market date. We have, oh, we're gonna need our vendor ID in there. Sorry. Added the vendor ID, got to put the vendor ID in there. Okay. What if we, so we have our, this is our, what's this? This is how much did each customer spend at each vendor for each day at the market. Okay, let's say, what if we want to filter to rainy days? How would we do this? We could, the cool thing about subquery here is that, sure, we know the market date info has a rain flag. Oop, helps to click the right one. Whether or not it's rained, whether or not it's snowed. If it's a 1, it rained. Okay, so we know that we could join market date info to go get the rain flag, and then we could do the where statement, right? But we also can just not do the where form, the join. We could just do it in the where, which is great because we're lazy, right? So we can just do where. And the way it works here is that all we need is what day was raining. Filter by it, rain flag. So what day, what dates was it raining? It's our concept here. So we'll open and close again. And we can start here with the market date info. And we know that the columns that we care about is the market rain flag. But we also need to make it in reference to a column that exists in the set that we're working on. So that's market date. So where market date is in, it's important that it's in because it's not equal, right? It's going to be a span, it's going to be mini, it's going to be a list, right? So where market date in, and essentially we're going to say the market date and the market rain flag, right? Okay, so we can get the market rain flag out of this. I'm not running this yet. We're saying, okay, we only want the dates that it rained. So we can put that in a where clause itself. So where the market rain flag equals 1. Now we have all of the days that it's rained. I haven't joined anything here. And the only thing that we need to do now is we actually don't want to select the market date rate. We don't want to select the market rain flag because our where statement doesn't care about the market rain flag. It only cares about this column, the market date. So what we've done is we've filtered by whether or not it's rained. When we go ahead and run this, we're going to go back to our original 4 columns. So these market dates are dates that it has rained. We can know that this worked because the result set, the rows is so many fewer, right? Take them all out here. Let's put a code block in. So we're at 244 with it, and we're at 2,727 rows without it. So we know it worked. We know that it came down here. And we can easily verify that on August 2nd, it rained. We can come to the market date info table, and we can check, and we can see that the market rain flag will equal 1 in that. So this is how we put it here inside a subquery. The subquery inside the where clause, right? When it rains. Let's do one more. Easy one here. What is the name of the vendor who sells pie? So we just want the name. And in the name, in order to do that, we would need to have the vendor name, the product ID that is pie, right? And we're gonna also need to know that in order to know the product ID in relation to the vendor, we're gonna need to have the vendor inventory. So we could join all that and we could write a complex filter that would work down here. Or we can just do it in the where clause, right? So we are going to select from our vendor inventory. So let's look at everything in the vendor inventory first. This is how we're going to get our product ID, which was going to relate to the product name, right? We've done the joins of product ID to product ID, right? To product and vendor inventory. We're going to need the vendor name, which is going to come from our vendor. So be our VI. You can look at that. Oops, sorry, click the wrong button. So our vendor name, that's actually the only thing we want for this query is the vendor name. So all the vendor names, we want them distinctly. We don't need them indistinctly. Okay. Now we know Annie's Pie sells pies, but let's act like we didn't. Instead of joining the product ID, we can just put it in the where clause. Where in, and it's in, it's where product, sorry, where product ID in. And we don't know the names of the products. There was no product name here, only product ID, right? Let's go back. There was no product. The only product things that we have was the name or the ID, not the name. We don't have product ID, product name in our vendor inventory table. So where our product ID is in, and we can go grab all the product IDs from the product table where our product name is like pie. And sure enough, what have we missed? If we forgot a semicolon, we forgot a semicolon up above. Hate that. Oops. Something didn't work. Why did that not work? Product ID 7. Exceptionally odd. Oh, I forgot to do the on statement. Thank you. Yes. Good sight there. Yeah. That's really weird that it didn't just err. It should have just erred. That's just exceptionally odd. Right? Equals v.vendor ID. Whew. Man, that would have been one where I've just been scratching my head like that doesn't make any sense at all. Okay, there we go. Annie's Pies. Imra, great point. I'm happy to happy to think of it that way too. Can we swap out to customer purchases? What's the name of the vendor who has sold pies, right? Slightly different question. I like this. I like this. I think that for the pies, they both sold, but I conceptually like there's a difference between who has sold pies, plural, right? Would actually, yeah, come from the customer purchases table. So we get the vendor ID on there anyways. But yeah, I love this. I love this statement. This is actually contextually different. These are two different questions. When we think about SQL, we are always coming from like the perspective of these questions are different. The inventory means that they sell pie, but the purchases is where they have sold pie. I think we're going to end up with the same results here. But in theory, if there were multiple pie vendors, maybe we would get something different, right? I think that's a really great thought. So just minor contextual difference here. Yeah, awesome thinking. Those are our subqueries. What questions do we have about subqueries? They are hard to wrap our heads around for the very first time, for sure. If you're struggling, stay for office hours, watch the recording, do the self-assessments, right? Can we show how to tab again? Yeah, so highlight the things you want, and you can just hit the tab button. Yeah, great one. Yeah, you can do it line by line, of course, too, but man, talk about irritating, right? Let's put this here in our code share. Yep. All right, where are we at? Okay. So we're going to run out of time. It's okay. I think we'll make it through temporary tables and CTEs. This means we won't get to datetime functions. Not a big deal. We'll get to them. But it does mean on your assignment 1, don't worry about doing the date, or work on it on your own, but like we won't mark you on it. We can talk about it and post the answer or something like that. But essentially, just from where we are and your assignment's coming due, you don't have to do the date thing. Don't worry about it. We will get through. Let's make sure we get through the temp tables and the CTEs. I love this question, Ritu. When you construct a sub, the subquery, what's best? The inside query first and then the outside query, right? Yeah, I think for sure there's kind of a mental model that helps. I think sometimes it depends on kind of how you go about thinking about it. I think when you are starting with this one, this item has been bought in the greatest quantity, it definitely made sense to write the inner query first, right? So sort of an inward to outward approach. I think for the where statements, it's actually kind of the opposite. You have started with your query and you're like, I want to filter it, but the filter is hard. And you're like, I could subquery it. That's kind of where that comes from. So I think it actually kind of varies between the two. But I think it is also kind of how your mental model comes to be. It's a really, really good thought. See what would make sense for yourself, right? Okay. Let's talk about our next 2 things here, our temp tables and our CTEs. Okay, so temp tables, temporary tables. They're table objects that we create on the fly. We instantiate them, we make them temporarily. And they're saved in a reserved schema called temp. The cool thing about temp tables is they're accessible across all your queries in the same session. So a session, like if you're on an actual server, you've like logged into the server, you've authenticated, blah, blah, blah. That's like a live connection, right? And that's called a session, right? When you have DB browser with SQLite open, that's your session, right? When you close SQL or your server connection is terminated, you lose your internet, that is when these are automatically cleared from the memory. You can chain temp tables in the same query. So you can put something in a temp table, and then you can take another temp table and put it into another one, and onwards, as many as you need to. If you're going to recreate them with the exact same name, because you're going to be creating them, you have to delete them from memory. We call that drop. So there's a difference between delete and drop. We're going to drop them if we want to recreate them. Some older versions of SQL don't allow for temporary tables. So we have CTEs on the other side. I'm not going to do think fair share just because I'm a little bit concerned about time. I think it's a good ideation of thinking about where temp tables are particularly useful. I think the gist of it is they're really, really good placeholders. And you sometimes are like, you want to take something into here and then do something else and then interact with them again. Right? If you have good thoughts, feel free to put them in chat. Let's do some live coding on temp tables. Temp tables. I personally feel when I code, temp tables are like my crutch. I like always go to them, like maybe a little bit too much. Okay, we have to introduce a we have to introduce a little bit of a logical construct here. To do that, if it exists, delete it, otherwise don't do anything. So we're gonna say, if a table named, and I'm gonna name it new, we're gonna call it new vendor inventory. Exists, delete it. Otherwise, do nothing. So we're going to do this for all the temp tables. We're going to always write this top little script here. We're going to say drop table if exists, and then the name of that, new vendor inventory. Okay, actually definitely hit the semicolon here. Hit the semicolon here. Okay, then we're going to make the temp table. Make the table. So we use create as our command. We're going to say temp to specify that we want it in the temp schema. And we called it new vendor inventory. And we say as. We're going to set the definition of this, what we want it to be. Definition of the table. So select star. And let's do our original price times 5. As inflation from vendor inventory. Okay, over here on the right, before I run this, let's collapse this. We are going to see that when I run this, we will see new vendor inventory change colors, and we'll see it come in here under the temp schema. I love it when I am I'm missing the semicolon. Why are you doing this? This happened to me last time. The code is absolutely right. What did we miss? Drop table if it exists. Nothing aired. Create the temp table as. You guys run it, see if it works for you. I feel like this is what happened to me last time, and I was like, why did this happen? I'll put it in code share here. See if you guys can debug it with me here. Drop table if it exists, have a semicolon. Create the temp table, the name of the temp table as select star. This is just a very plain new value. Oh, I did it without the semicolon first. Why are you not working? This is very annoying to me. No, we don't need an end. Somebody else run it and tell me if you get temp tables appearing here on the right. Like, not getting it either. Nothing happens. No. Okay, let me go to my. I definitely need the as. Let's not have the drop table. Kevin, is yours different? Yeah, see, now it's saying that new vendor inventory exists. It's like it's stuck. Why are you being like this? Wow.
I just changed the table name, the temporary table name, and I run it, and I was able to see in the temp table.
New vendor inventory. It's like it exists. It obviously exists, but it's not displaying it. This is very annoying to me. All right. I apologize that we're not seeing it.
Actually, you would see under temp table, but you're not seeing the temp table. We were seeing temp table.
Or
Not
we
the
should
table.
see it here on the right.
Right. You're not
We
seeing, but we
should.
are category. You don't have it.
All right. Well, what do we
I
do?
used it with the temp. When we create the temp table, I use it with temp.new inventory, new vendor inventory. It shows up in the temp.
And that's what did it.
It showed up for me at least. Like
It's like it's not showing up for me no matter what, even though we know that it's working. Let's do it this way. No. All right. Well, we will not. I will play with that. It does work. I know it works. the schema definitely should refresh. I'm super annoyed. I don't want to get too bogged down in the annoyance of it. It's working here, though. We know. Here, I can prove that it's working. Come over here. There's no code here, right? There's no code. I've put my select star. And we have a result set. So it's working, even though for some silly reason it is not RAM. Yeah, I don't know. Maybe I'm on Zoom.
I think if you reopen, you would see it. I think it's just a refresh problem. If you reopen the browser, you might see it.
Yeah, it's
Just a
extremely
refreshing problem.
incredibly bizarre. Let's not worry about the visual aspect of this here. We have made our temp table. Let's put it into a new temp table. Put a temp table into another one. Same thing here, drop table. If exists, the new vendor inventory. Can keep proving that this will work. We can create our table. We did temp.schema, it's the same thing. We can do temp.new vendor inventory as select star from our temp. Let's add a inflation ×2 here as our super inflation. Here we're taking our original temp table and we're chaining it in. We're creating our super inflation value here too. Look, now it's going to work. It's going to give me both of them on the fly. Here we go. Temporary table. Very bizarre. But here we go. We see that we have our two tables, new vendor inventory, and our new vendor inventory with our respective inflation and super inflation. We can browse them. Temp.new vendor inventory. So we have made our temporary tables where we have had our inflationary periods for whatever reasons. So it's nice to be able to put them into one another. When you have complex things, sometimes you'll put something in a temp table and you'll work on it. And you put something on a temp table and you'll work on it. And you're at the very end, you'll smush everything together. It's a great way to think about, have multiple contexts in play where you're having these minor differences. Maybe, you know, actually it's super interesting when we talk about this minor contextual difference between sold versus sells pie. This could be a great use where you want to somehow compare these things. Temp tables are probably going to be a great way to go about that, where you're going to put something in that is the sells pies versus the sold, and then you're going to compare those two sets against one of them. And you can make that query into this concise single query at the end based on those two temp tables. I really like that we came to this as kind of a favorite thing. So temp tables here, you can see that we're able to get new vendor inventory in another query window, right? Yeah, Irna, you're probably referring to the hash is typically like the Microsoft version of this. So just slightly different constructs for different flavors on this.
But it's just,
Yeah, sorry, go ahead.
I just wanted to check, it's, the idea of this is the same, so, because I used to work it into the Microsoft,
Yep.
I would select whatever I need to select, and I put it into the temp table, and then from,
Yep.
it's the same thing, right?
The same thing. Yeah, yeah. So there's actually multiple ways you can insert into, you can create into. There's just different kind of, it's all kind of the same idea. You're putting a result set into a named object in the temporary schema. So different ways to go about it.
Thank you.
Yeah, great question. Yeah, so the purpose of the temp table is like when you have a lot of complexity and you're starting to have to kind of like placeholder something temporarily while you work on something else with the ultimate goal of like combining them. Let's talk about when we don't have the ability to do temp tables, but they're in the code share. Okay. Oh, I think we went too far ahead. Okay, sorry, we went too far ahead. So now we're coming to common table expressions. They're pretty similar to our temporary tables. And we have to just like contextually know that CTs were developed before temp tables were. And so some older versions and maybe some flavors are still out there, might not support temp tables. So you do really need to know how to do CTEs. What you should think of them as, what we just did was instantiating tables on the fly. Here, we're going to instantiate a query result on the fly. And we're going to use the with command. Say many of the RDBMSs require a semicolon terminating the with command. So again, going back to, is the semicolon needed? And I would say, if you are going to do multiple CTEs, don't use more than one with clause, but instead just follow the CTE with the next CTE with a comma. So the first CTE, comma, the next CTE, and then it's written, these are all written before your final select statement. Sometimes it's easier than a subquery to do a CTE. Sometimes if you have a little bit too much complexity, it can be harder to read. Also stored in memory, but limited to your current query window only, right? So the temp tables, which is, I think, why I like them a little bit more than CTEs, but they coming later on, is that you can access them across the query windows, right? These only instantiate when you hit run, and then they're gone. Let's do one. This is one of my favorite codes, CTE for the farmer's market. We're going to calculate the sales per vendor per day. So it's really similar to what we've been doing with our sum statement over and over again. I told you guys we'd write that one a million times. Where was our last one? It was here. And the subquery is where? Because it's our per day, right? Let's call this as, I forgot my group by. Market date. And let's call this sales instead. We're going to change the perspective here. We're going to talk about vendors instead of customers, but it's still going to be the same. Okay, so let's add a little bit more information because I'm going to turn this into a CTE where what we're going to do is we're going to take the daily sales and we're going to turn them into a weekly sales instead. So what we're going to do here is we're also going to clean it up a little bit. We don't care about the customer ID. We do care about the vendor ID. Could have been. And we don't want the vendor ID. We want the vendor's name because this is our sales report. So we're going to interjoin our v.vendor on v.vendor ID equals cp.vendor ID. Going to need to put my alias on CP. We can get our vendor name. Let's also go to get more information than just the market date. Let's go to the market date info table and go and get some of those date values like the day and the week and the year. Instead of actually just the date, we'll have more than that. So we will interjoin our market date info, which is just a date table, right? The dates that the market is open. Call that MD on cp.marketDate equals md.marketDate. Let's pay close attention here. We need to alias these so we don't get ambiguous columns. And let's grab the columns that we wanted. Market day, market week, market year. This is now our sales report. It's really lovely. Let's run it. And it says, hey, Marco sold $76 worth of peppers on Wednesday, the 15th, 2022. Annie, you sold 399 pies. Great job. And onwards, all through the farmer's market history, right? Okay, so let's make this a CTE. This is just a nice query. If we want to change very easily from day to weeks, this is a great CTE example where we can come in and we can come to the very top and we can say with, and we name the query. The name of this query was the vendor daily sales as, and we open a parenthesis I'm gonna close a parenthesis below it. This is now the CTE. I've tapped it in. And we can come in down here and we can re-aggregate the daily sales for each week instead. So we will just select from our vendor daily sales. Now look, it didn't help us with the, like, it doesn't know about the name vendor daily sales because it doesn't exist until you run it, and you can't run it until you finish this. So just know that with CTEs, there's nothing in memory, so there's nothing it can help you with. It's going to always have to type these things out. So it's our market year and our market week and our vendor name. And really cool, because we're changing from daily sales to want to go to weekly sales. So we're aggregating around, we're changing our aggregation layer to, instead of doing the days, we're going to do the weeks per vendor. So Annie on week 15 and Annie on week 15. We're going to combine those two rows. We're going to do the same thing for Marco, right? We're going to actually do the aggregation here on our sales value, because that's what's in the CT. That's what's in the CTE. So we don't have to do this reaggregation, and we don't have to do all this summing on this again. So we're going to do a sum on our sales. The name of our column. We do need an order by, because we're going to do another sum, right? On our market year and our market week and our vendor name. And so we're taking something, the daily sales, and we're re-aggregating them onto the week instead. Oh, I typed order by and I meant group by. Group by. There we go. And sure enough, we aggregated those two values. So week 15, let's go back. Let me run this again. 836 50. 836.50. If we do 399 plus 437.5, yeah, 836.50, right? And 76 and 112, right? So 188. Is that what we get for Marco for week 15? Sure, perfect. So see how we took that top query, we named it vendor daily sales, we re-aggregated it, the sales that happened each day, and we did it on the week. We could have, instead of the week, now we have this really easy way to come in here and say, not the week, just the year, right? Here's how Annie did in 2022. She's crushing it, right? She's made a lot of great pies, right? So we don't have to rewrite a whole lot to change from week to year. That's a cool use of the CT. Of course, we could do this, have done this with a temp table, but the notion here is the temp table is a little bit like we're saying, what if you don't have the temp table, right? Could you have done this in a subquery? Sure, sure. Could have done this in a subquery too. Might just sometimes be a little cleaner, a little more consistent to do in a CT. Sometimes with SQL, there's more than one ways to go about it, and you have to sort of decide, and sometimes it's good, sometimes it's bad. Maybe it's because you want to do more joins to it here, you know, join something here. And so it's actually just a different way of going about it. So sometimes it's a good question, Tom. CT is better in terms of performance. Putting things in memory, if you have a lot of memory available, is a pretty good way of doing things instead of just the query engine. I would say CTs are probably not the most optimized way of performing, but versus a subquery, we'd have to really research it. We could in like an enterprise tool, we could use like an execution plan and we could compare. It'd be really interesting to know. Hard to answer off the top of my head. Omar, hand up, please.
Yeah, Thomas, just a quick question. I think you explained it 1,000 times, but just a reminder for the inner join, and then you've put the on. Why would we do that with the tables? Can you explain that briefly, please?
Yeah, so here, the reason we're inner joining is we want the vendor name from the vendor table because it's not there. And we want the market day, market week, etc. What's the last one? Market year. So it's to gather more columns
Yeah.
of meaning.
But I mean, in general, why wouldn't the inner join, we use the on? What does it mean, the line on, and then we put the name?
What does the line on mean?
Yeah.
That says what column matches. So go back to our Excel. The thing that matched on was
Oh, got it.
our postal code. On postal code. That's the thing that's matching.
Got it. Okay,
Yep,
okay. Appreciate
yep.
it. Thanks.
Good questions. Okay. 8:20. We won't go forward into the date times. So don't worry about the date time question. I think it's only one, maybe it's two. Don't worry about them on the assignment. We'll talk about what the solutions are. I'll post the solutions, you know. Feel free to do them if you want to go through the slides and do them, like, more power to you, but I'm just gonna say, like, you won't be marked against it. So I'll communicate that to the learning support clearly. What questions do we have about any of the aggregate functions, the subqueries, the CTEs? We'll come to the date time on Tuesday. Ritu, I hardly see industry CTEs being used. I think that's a good thing. I think that's a good thing. I think that the annoying thing about subqueries is like you can't run this, right? Incomplete input, right? Yeah, and Davida, to your point too, like you know, can we, you know, can you use it again, you know, as a function or something? No, you would like make it a view or make it, you have to like use these other components, right? So a CTE is like, I think of kind of a narrow use, and I think Ritu, you makes a good point that you're not seeing them as often anymore. I kind of like hearing that.
Yeah. So in the assignments, we have a lot of CTE assignments? I haven't got a chance to see them. That's what I'm asking.
I think there's only one question. Let's look at A1 real quick.
Since we have some time left, can you walk us through with the assignments?
Sure. Yeah, let's talk about the assignment. Okay, so assignment section 1, I think many of you have worked on. It is making a logical model, right? For some of the tables that I did not do the very first day, right? For section 2, there is an assignment 1. Oh, did it get renamed? Oh, I have, okay, I think there is assignment 1 SQL. There is an assignment 1 SQL. Bring this into your DB browser and write out your answers here. Yeah, to the question of was there a, oh no, I only did temp tables. So yeah, no CTE in the assignments, because I think you could just learn temp tables, but you just need to know that CTs are out there just in case somebody asks you, you know about the construct of them, right? So you're going to fill in for the assignment 1. You're going to build your diagram for section 1, right? So you're going to upload a PNG, right? It's going to look like this, right? And then for sections 2 and 3, you're going to write the SQL code, right? Just as a thing worth mentioning, and I put it in the Slack here, always good. Like I'm putting lots of information. If you're not checking the Slack, do please check the Slack. If you are coming to this, use this open SQL file to go and to navigate to your assignment1.sql file in the O2 activities assignments folder. Hit open, write your code here, save your code, push this and your image to your branch, right? So select star from customer, right? That's definitely answer 1. Save this, and when you are doing your push, right, this is what you're submitting. This plus your image, right? All of this is really, it is written out up here, right? What you want to submit. 1 entity relationship diagram, 1 SQL file, right? Same thing for assignment 2, but you'll also submit the markdown file with a filled-in answer. Other questions? Other questions?
Just quick.
Balash?
Thank you. So for this week, we are due with assignment 1 or both the
Right.
things?
Right.
Oh.
So do assignment 1, but I am saying you don't have to do the date questions.
Okay.
Yeah. I think there was one other person who had a question.
Yeah, just quickly, Thomas. This is
Yep.
Hira. I understand that the code, our live code, the correct ones were posted in GitHub
Right.
after the code. Could you please identify the folder name so that I
Yep.
can go?
Yep. So in this cohort, you will find our custom slides and our live code. So here's our in-class live code, and you'll see it's broken out by module. So module 2, that was yesterday. You'll see all the things that we have in there. These were the case statements, the distinct, etc., that we wrote yesterday. I'll put the multiple table joins in there.
Thank
And then
you.
module 3, it'll be empty right now. But when we conclude class, I'll go and save them, refresh your repull your thing, and you will get the module 3 live coding. Yeah, thank you, Niels, putting that in there.
So Thomas, hello.
Yeah, please go ahead, Patel.
Yeah, so we have to submit the charts and assignment 1, accept only the date time
Right.
queries, right?
Right. Just because we
Okay,
didn't get to the
got
date
it.
time functions. Yeah.
Okay. Thank you.
Thank you, guys. Rayhan, please.
Hello. Sorry, I was just trying to look at how you were saying to open it and
Yeah, let's go through that again. So we have the database open, right? And when we're here in the execute SQL tab, we have this open SQL file as an option.
Actually, just to clarify, so those of us on Windows, the open SQL file doesn't exist. The text doesn't exist. It's just a symbol.
It's just the symbol. If the text is an option, you guys can enable in your preferences. The text appears under the icon here in execute SQL.
Oh, okay, stay on. I'll put a screenshot.
Yeah, it was really difficult to find because it doesn't have the text.
where?
Yeah, just
Sorry?
take the screenshot of the settings.
I wish they turned it on by default.
No, not really.
Where?
Turn on execute SQL, the text.
Sorry, how did you get to this?
This is either your preferences or your settings. So is it the control comma or command comma?
Got it.
Yeah. Yeah. The text appears under the icon. Yes. Okay, so it's your second button if you haven't done that. This little such a small, this is so small with the icons, right? So open that up and navigate to your assignment 1 SQL, right? So it's in your O2 activities, assignments, and assignment 1 SQL, and just hit open and then code in here. You can also drag and drop this too, but it's just best to do it, I think this way, just the open SQL file. And then remember to hit save SQL file, the button next to it, right? When you're done, save the SQL file, right?
Actually, I am unable to get the file. Can you just tell another time so I can able to see my file and load my file?
Say that again.
I think she wants you to show her it again.
Yes,
show one more time?
Yes.
Yeah, let me close it. Okay, so we go for here, open SQL file, and we're navigating to where we have our GitHub folder, and it's in our O2 activities, and the assignments folder within that, and then it's assignment1.sql that you have your code to write in.
Actually, I do not able to find in my Windows opens SQL files. So how should I?
It will be your second button.
It's only.
It's a little icon. Second icon.
Yeah, I think if someone puts a screenshot on Slack, I can go and I can circle it or go and enable those preferences. I'll drop a screenshot of the preferences in Slack too. Good. I'm glad we asked that. It's a good question. One more thing before I think we'll, as Calvin has dropped you a nice image here, right? It's your second icon here, right? This one. Open. The third one here, that's save, right? That's what we want, right? Open, this one here. Yeah, thanks, Calvin. Thanks, I got there too. Oh, it's like even, yeah, got that marked. Appreciate that.
Promise.
Yes.
Have you finished slide number 3 today?
No, because we got dates to get to.
Okay.
Yeah.
So we're done until slide number 3, but except the date one.
Right.
So slide 4, 5, 6, exactly what are we learning there?
Let's get to it. Let's get to talk about that next week.
Okay, yeah. Sure.
Yep.
Okay.
I mean, you're welcome to open them up and browse them yourself too. Absolutely. Yeah. Okay.
Now I can able to see SQL file. But while we are just saving the code, we have to save this code and commit this SQL queries upon like my repo, right?
Right, on your assignment 1 branch. And these
Okay.
details are in the files. When you look at these, there are these details in the assignment 1 markdown that specify exactly what to do, right? Name the branch, assignment 1, right?
Okay.
It should be on your GitHub username, SQL, polls, pull request ID. Yep.
So while submitting the core SQL queries along with PNG, so we do have to commit all of together, or we can do separately as well.
You can do more than one push, but it's going to be one. It's going to be one commit at the end that the LS goes and looks at.
Okay.
Yeah. Reach out on Slack to learning support or hang out after here for more questions. I want to say one more time, and then I'm going to stop talking. Remember, no work period tomorrow because of the holiday. Everyone, there is one on Saturday, but no work period tomorrow. So thank you all. Learning